Hi guys, welcome to another video by TechMe Academy. So today I'm going to be covering AC sinusoidal waveforms. We're also going to be looking at crest factor and form factor.
This is from start to finish. We'll call this a period. To top, we will call these the peaks. This is a peak. Right. Okay, and then obviously this will be peak, this will be peak, and then from top to bottom will be peak to peak, which isn't very difficult to understand. Now, frequency is 1 over time. Now, frequency here in South Africa is 50 hertz. So what is the time per period? So if we go 50 equals 1 over t, we can derive t as 0.02 seconds. So this is how long a period takes to complete itself in the 50 hertz frequency range, right? So we use 50 hertz, so each period is 0.02 seconds. All right, that's easy enough to understand. So another key concept to understand is that we don't measure voltage in peak. We measure it in RMS. This is very important. So what is RMS? Now, RMS is basically the DC equivalent value that will create the same heating effect. Because if you look at it, it basically goes up and down. So over a period, your net would be 0 if you integrate this. If you integrate the top and the bottom, it basically comes down to 0. RMS value is the voltage peak times 0.707, correct? This is equal to the RMS value, right? So RMS value is very important. It's very used and it's fundamental to electrical engineering to understand the RMS value. What's another one that's important to understand is the average value. Why is the average value important to understand? Well, because people often use it in crest factor and form factor, which is something I'm going to come to right now. The voltage peak times 0.637. Voltage peaks times 0.637 is considered average. Average voltage. RMS voltage, average voltage. All right, cool beans. Now we've gone through those principles. So things that you can clearly see is we have a waveform that goes past the 0 reference over here, and it goes up and down, and we've discussed frequency, we've discussed period, we've discussed peak, and we've discussed time of the period for 50 hertz. Form factor of a sinusoidal waveform, form factor, is equal to RMS value over AV. RMS value over average value. All right, so let's start. Let's say our peak was 100 volts, right? Let's say our peak over here was 100 volts. 100 volts, meaning obviously this bottom peak would be minus 100 volts. You get the memo. So let's go over and say our peak was 100 volts. Easy, we insert it into the formula. For
The ones we don't know is what is the RMS and what is the average value, right? 100 times 0.707. 100 times 0.637, if you remember. So this will basically be 70.7 volts. And this one over here will be 63.7 volts. All right, so for form factor, we have RMS value over average, and for crest factor, we have max over RMS. So our RMS was 70.7, so let's just go and write it there. Right, over average, which was 63.7. And then for our crest factor, we had max, which was 100, over RMS, which is 70.7. All right, so let's go and take a calculator here quickly and determine 70.7 divided by 63.7, and take a look at the crest factor, which is the peak max over RMS, which is 100 over 70.7. This equates to about 1.4144. All right, this concludes today's lecture on form factor, crest factor, average value, peak value, period, and frequency. I hope you guys enjoyed it, and tune in for 1.6 and 1.7.